For the next two problems, the base of our solid is going to be the circle x squared plus y squared equals 4. Well, I know the equation of a circle, or Pythagorean theorem, is x squared plus y squared equals the radius squared. So the radius is 2, and you can tell because there's nothing in parentheses paired with the x or the y. It's centered at the origin. So I have something centered at the origin that's 2 out in each direction. Well, we're looking for cross sections to be squares or to be semicircles. If I look at this, I know that for squares, I'm going to integrate side squared. Now, our cross sections are going to be perpendicular to the x-axis, and that part has to be given to you. So I know it's going to be a dx. So this first part is easy. If it's a dx, then I know my limits of integration are going to be x values. So where does my circle start and where does it stop? Well, if it's centered at 0 and has a radius of 2, r squared equals 4, then I know that my x values will go from -2 to a +2. The problem people have is that they don't know what to put inside of here. Well, there's lots of different ways to look at this, but let's just say that you're trying to put this into your calculator, so you knew you need to solve for y. So I'll say y squared equals 4 minus x squared. The next step would be to take a square root. So y equals plus or minus the square root of 4 minus x squared. Well, each one of these, the positive square root and the negative square root, represents a semicircle. The positive square root of 4 minus x squared is the top. It has positive y values, so that's the top of the top semicircle. The negative will be the bottom semicircle. So when you look at it this way, as if it was two different functions, you have like a y sub 1 equals the positive 4 minus x squared, and that is the more positive function, and then y sub 2 equals the negative square root of 4 minus x squared. You have it. So I have a more positive function and a less positive function. As I said, the cross sections will be perpendicular to the x-axis, so for squares this would represent one side length. The square would come up, over, and down. And of course they get smaller as you head towards -2 and 2. So the more positive would be the square root of 4 minus x squared minus the negative square root of 4 minus x squared. So when you subtract the negative, you have a plus right here. And so this could also be represented as 2 times the square root of 4 minus x squared. And it could be written there. If you actually squared that, you'd square the 2 and you'd have a 4 on the outside. Have my integral from -2 to 2, and then I'm squaring the square root, so it would be 4 minus x squared dx. And that's what I would integrate if I had square cross sections. For semicircles, it's going to be 1/2 pi, the integral from -2 to 2 of my radius squared with respect to x. My radius, I'm taking my diameter, which is the same as this, dividing by 2. So this would be the integral setup. If I simplify it, the 2's could cancel. Then I could square the square root. So I have pi over 2, the integral from -2 to 2 of 4 minus x squared with respect to x, and that would be the answer.